Fiber optic cable, it seems like it's the perfect thing for communications, and it is, but even it will have its flaws, and you find those sometimes as you go up to higher bit rates. Jim, as the Fiber Optic Association, you've been looking at fiber for years and years and years, before that Photech. Why don't you tell us about some of the experience that we were talking about yesterday as far as the degradation of fiber as you go up to these higher bit rates?
Everybody thinks fiber has infinite bandwidth, and nothing has infinite bandwidth. But the other thing is that fiber started, when we were starting in it, the first fiber systems were running at 100 megabits per second. Now they're running at 100 gigabits per second, 1,000 times faster. Over the course of 30 years or so, the manufacturing and design of fibers changed to accommodate faster speeds. It turns out that a lot of organizations, which includes government organizations, commercial organizations and the like, have a lot of old fiber in the ground or in the air, which is even worse. And all of that fiber is, if it's older, is going to be of an older design and a slightly different manufacturing process. And the big difference is, will it support higher bit rates, faster systems? And there's only one way to find out, and that is you have to test it.
And that's the thing, you have this asset in the ground, and a lot of times the city or whoever might have put that in the ground really have no idea how it's going to perform, right?
That's it. Think of it as an old concrete highway that all of a sudden you want to increase the size of trucks to double the weight. Well, that's where we're at. We want to double the weight or go 10 times higher in bandwidth. And in order to know if it's good, we've got to test the roadbed.
Well, one of the things, I couldn't really get my hands around why you'd want forward error correction in fiber, but when you have things like maybe even the wind or something, pushing the fiber around, I guess you can have changes to the characteristics of the fiber, right?
Yeah, there are ways that the fiber disperses signals, spreads them out. Some of those ways you can compensate. There's a thing called chromatic dispersion, which is caused by the wavelength shifts in the light. Those you can put fiber in that removes the chromatic dispersion. The other topic, which Greg talked about a lot, was polarization mode dispersion. PMD, as we call it, is due to two factors. One of them is the geometry of the fiber. So if you have a fiber that's not completely round or not completely concentric, you can have problems with PMD. But you can also have problems when you stress the fiber. So if you take a fiber that's under stress, it changes the polarization of the light. The two orthogonal modes, is that too big a word to use? Everybody who knows about polarization knows you talk about orthogonal modes of light. And if you put stress on the fiber, those two modes travel at different speeds. And so you get dispersion. And if you put stress on a fiber, it'll change it. So you can take older fiber, which is less compensated for it, and you can, for example, use it to measure the wind speed. If you have high wind conditions, you'll have more variability in PMD. If you have fiber buried along railroad tracks, you can see when a train passes, because of the vibration it causes. And that's one of the things we've learned from all the testing that's been done. People find strange things happening in dispersion, and sometimes they're simply because of physical changes in the environment.
Well, you've thrown around a lot of big words, and I think part of what the Fiber Optic Association does is help people understand those words and understand the applications and how this stuff fits together, right?
That's our job. I like to quote a quote from Arthur C. Clarke from the late 50s in one of his science fiction stories, and that is that sufficiently advanced technology is indistinguishable from magic. Well, welcome to sufficiently advanced technology. It's not magic.
And a big part of what you just spoke about was helping the workforce of tomorrow, really today, build that fiber optic network.
Exactly, and our job is to make sure that the workforce is well trained, that they know what they're doing, and they have the knowledge, the skills, and the abilities that are needed in order to successfully do the work.
And what impressed me was the way you work with institutions that are really at the ground level, whether it be companies or community colleges.
We work with everybody. We have programs where we work with everybody from individuals or small contractor groups all the way up to colleges and universities, where we integrate our programs into theirs because of its broad applicability to a lot of different typical subjects.
And it truly is becoming just a subject in a bunch of disciplines, right?
That's it. If you're doing work in telecom, you need to know fiber. IT needs to know fiber. But industrial work, every factory is full of fiber. For example, the electrical smart grid is based on fiber. Fiber is ubiquitous. You cannot communicate in today's world without doing it on fiber. When you use your cell phone, it's wireless only to the antenna. The antenna going down the tower and from the tower into the phone system, that's fiber, man.
Well, it looks like there's a continued bright future with fiber. So, Jim?
I think so.
Thanks.
My pleasure.